Let us discuss about the working of the temperature measuring systems. So here I am using RTD to sense the temperature of the boiler. This RTD is connected to analog input module, and this analog input module is communicating with the PLC. And D100 is a sample memory location which is available inside the CPU. So here I am mentioning PLC. It may be a microcontroller or it may be a microprocessor. So now suppose if the temperature is 0 degree Celsius, then your RTD will produce equivalent analog value. So if it is 0 degree Celsius, it will produce 0 volt. So this 0 volt signal is given to analog input module. Your analog input module, it converts the analog signal into a digital value. So now it is producing 16-bit digital values. So equivalent 0 volt equivalent 16-bit value will be 00000000. So this value will be stored in the PLC or controller. So where it is stored? It is stored in the memory location D100. So normally this 16-bit data will be converted into decimal value. So the decimal value will be stored in the data register D100. It may be D200, D300. It is only for an understanding purpose. Suppose if the temperature is 10 degrees Celsius, then it will produce 1 volt. So the equivalent binary value will be 000001000 something 16-bit value will be produced based on the analog input. Again this binary value will be converted into decimal value, which is stored in the data register D100. This data D100, it is not a separate hardware. It is available in the PLC. It is a one type of memory location. Suppose if the temperature is 20 degrees Celsius, your RTD will produce 2 volt. The equivalent binary value will be generated by analog input module. The decimal value also will be generated and it is stored in the memory location D100. If the temperature is 50 degrees Celsius, RTD will produce 5 volt. So based on the voltage, it will produce the voltage. Based on the temperature, it will produce the voltage. That voltage will be given to analog input module. This module converts the analog voltage or current into equivalent binary value. The number of bits, here I am mentioning 16-bit, but it may be 8-bit, 12-bit, 13-bit, 14-bit, 15-bit, 16-bit. It depends upon the type of analog input. When the number of bit increases, the resolution of the analog input module also increases. So now it is producing 16-bit digital output. The equivalent binary value, decimal value will be stored in the memory location. If it is 100 degrees Celsius, then your RTD will produce 10 volt analog signal. This voltage signal is given to analog input. It is converted. Then all the bit will be 11111. The equivalent decimal value will be 16,000 and it is stored in the PLC memory, PLC or microcontroller memory location. So this is the working of the temperature measuring system. So here we have to note this point. Your analog input module, it accepts the voltage and it converts the voltage into number. Finally we are getting number 16,000, 8,000. So analog input module is nothing but it converts voltage into number. So here it is voltage or it may be a current signal. So what are the different types of ADC? One is a counter type ADC and second one is a parallel comparator or flash type ADC. Third one SAR, successive approximation register type ADC. Fourth one sigma delta ADC. Fifth one dual slope integrating type ADC. So these are the different types of ADC. So in our future lecture we will discuss it one by one. Thank you.